In this video, let me deal with the relationship between Fischer and Haworth structures. And I'm going to do it just for D-glucose here. Oftentimes, just like a lot of things in chemistry, science, you take one example and what you say about it can be applied to many other examples. And that's certainly the case for D-glucose in the context of this question here. Let's look at the Fischer projection for D-glucose. That's an aldehyde, shorthand or condensed structural formula for an aldehyde. Right. D-glucose is an aldohexose. Aldehyde functional group up top, and then 6 carbons, with the 4 in the middle being chiral. And the particular pattern for glucose is this. Right. D-glucose means this. All right. The D means this lower hydroxy group is on the right-hand side. And then to be D-glucose, then the other hydroxides have to have this particular pattern. And you see that alternating form up here between the 2 and the 4 carbon. And then these other positions will be hydrogens. Great. Let's compare that to the Haworth structure. I'm not going to address it here, but in the Haworth structure, this is an equilibrium reaction. This oxygen's reacting with that carbon. And in the process, the carbon-oxygen double bond in the aldehyde functional group changes to a hydroxy group, an alcohol functional group. And when it reacts, it can either be pointing up or pointing down. And I'm just going to point it up here just arbitrarily. And since it's pointing up here, then I have to put this beta tag in front of the D-glucose. Okay, so here's our two structures. Let's specifically sort of address this question. Hydroxy is on the left on the Fischer projection. Well, that would be that guy. Which one is that? There's our 1 through 6. And then the 1 through 6 here, the 1 is starting there. And the 6th carbon is always a CH2OH pointing up. So that's the 3rd carbon. Any hydroxyl group that is on the left-hand side of the Fischer projection is going to be on top in the Haworth structure. And then just in the context of this question, let's just edit the question a bit and just say what the student's referring to the outside, I'm going to refer to as the top side. That's just the way I think about it. I think about the carbons and this oxygen making up a plane, and then the way I'm viewing it, this is on top and that is on top. Let's address the other ones while we're at it. So if I look at the 2 and the 4, if I have a hydroxy group on the right-hand side here, okay, right, these are not involved in the chemical reaction that converts the Fischer projection to the ring structure. So I'm not addressing this one, it's just these two. If it's on the right-hand side, then it's going to be pointing down in the Haworth structure. And that's true for any of the monosaccharides going from the Fischer to the Haworth. Occasionally, and I think our textbook does this, you'll see this sort of discussion. Imagine that this vertical Fischer projection sort of falls on its side in this way. And so what happens to these hydroxy groups? Well, they point down, and then the hydroxy groups on this side are going to point up. And I think that'll do it for this question.